My name is Christophe Delmotte. I'm with the Belgian Building Research Institute, and today I would like to talk about repeatability and reproducibility of building airtightness measurements. Let's imagine the same technician with the same blower door measuring twice the airtightness of the same building. How different could results be? So imagine two different technicians with their own blower door measuring the same building. How different can be the results now? In order to answer these questions, we ask our technician to measure 10 times the same building. It means it's under repeatability conditions. And then we ask 10 other technicians from other labs with their own blower door to measure also the same building. This was under reproducibility conditions. We used a building that is located in our premises in Belgium, so it was very easy to make the measurements. It's an unoccupied single-family house built around 1980, and we measured only the ground floor. So you can see the picture on the screen and the plan of the building. We used the standard EN 13829, which is ISO 9972 slightly modified. We take measurements from 10 to 100 Pascal with increments of about 10 Pascal. So it means we respected the standard. The tests were made during the summer 2011 under good weather conditions. Everybody used a Minneapolis blower door except one lab which used a Retrotek. Everybody used electronic manometers with automatic software. So it was really easy to record the data and to send the results and to have all information about the measurements. Results of the repeatability measurements are shown on the screen. So it's the results obtained by the same technician. 10 different measurements done by the same technician, and you see that there is a spread of the results, of course, and you see that there is a large difference between depression and overpressure. So, since in reality, under natural conditions, there are never buildings fully under depression or fully under pressure, it seems preferable to favor test in both modes and take the average, to have something which is more representative of natural conditions. On the screen, you see the standard deviation of the results. And as you can see, there are more variable at 4 Pascal than at 100 Pascals. The reason is that the measurements themselves at 4 Pascal were more variable than at 100 Pascals. And if you see the standard deviation at 50 Pascal, you see that it's about 1.4%. But if we now come to the repeatability limit, we see that it's 3.8%. It means that the absolute difference between measurements can be expected to be less or equal to 3.8% with probability of about 95%. The results I've just shown were obtained with unweighted regression, but some people tend to favor a weighted regression, so we did the calculation again with a weighted regression like it's stated in the Canadian standard, and we found these results. For 50 and 100 Pascal, you can see that there is no large difference between both But if we come to the results at 4 Pascal, you can see that the standard deviation is quite lower. I'll come back on the first results. So it was 3.5% and it's now 2.8%. So weighted regression could give lower variability of the results at 4 Pascals. There are also people who try to measure from 30 to 70 Pascals in place of 10 to 100. And we used the result we had to make the calculation from 10 to 100 or 30 to 70. And as you can see on the chart on the screen, there is not a large difference for the results at 50 Pascals. And if we compare the standard deviation of the results, you see that, yes, the standard deviation is a bit higher for measurements taken from 30 to 70 Pascals. But remember, this is for the results at 50 Pascals. Maybe if we go to results at 4 Pascals, the variability will be higher. We can also compare the confidence interval calculated according to Annex C of the European standard. But you see the chart, probably this is underestimated if we compare it to the repeatability confidence interval we obtained with the measurements. Maybe it's a good idea to revise or to calculate it otherwise, but this is now under discussion in the revision of ISO 9972. In 1990, somewhere in that time, there was an article from Murphy saying that the standard deviation correlates with the air leakage. So we made 10 supplementary tests with a lower air leakage and 10 other tests with higher air leakage, but we cannot find any correlation between the air leakage and the standard deviation. You can see on the chart with the blue dots or the red or green, there is no real correlation. So it does not mean that there is no correlation, but it means that we cannot strengthen the idea that there is a correlation. If we come now to the reproducibility measurements, it means those made by different laboratories with their own blower door on the same building with the same preparation. You can see that there is a larger spread of the results. Of course, this is normal. And if we see now the standard deviation of the results, you can see that it's about double of the repeatability measurements. And the reproducibility limit for measurements at 50 Pascals is now about 7%. So it means that the absolute difference between two measurements made by two different people can be expected to be less equal than 6.7% with a probability of 95%. Before I finish the presentation, I would like to thank our sponsor, which is the Walloon region of Belgium, and of course thank all the participants of our study. And I thank you for listening.